Hi and welcome to the video on the binomial theorem. I think you'll find this in chapter 1, almost exercise 1 I think. Some of these types of questions. Binomial theory is a really good way of expanding brackets to the power of 1 or 2 or 3 or 4 really quickly and efficiently. So let me just jump straight into it. We're going to consider the expansion of the binomial powers. So x plus b, b is just some random number to the power of 0 is just 1. X plus b to the power of 1 is 1x plus 1b. So on and so forth until you get down to x cubed, where you have to do x plus 3 times x plus 3. Do the expansion of that one using FOIL, and then do all of that times x plus 3. It can be quite long and tedious, but that's how we would do it. And then x, those ones you could probably do by yourselves without too much issue. But then x to the power x plus b to the power of 4, there's just a lot of work involved in it. It gets quite tedious after a while. But if you did, you would get the answer that we've got here. And then I think we go x5, and yeah, that'll be the last one. I guess what I want to notice here is patterns. I want you to see that there's a 1 on the outside of all of these things here, and there's a 1 on the outside of all of these things here. And then if we go down into the next little diagram, this shows all of the coefficients. Okay, so as you can see, the 1s are all down the side there, so the coefficients of these terms all along here. The 1s are all the way down the side, and if we have just look at the last line, x something to the power of 5, it's 1, 5, 10, 10, 5, 1, which are 1, 5, 10, 10, 5, 1 here as well. So the thing that we can do is we can actually get each line by adding the two previous points, two previous numbers to get the next one in this diagram pattern here. So 1 plus 2 is 3, 2 plus 1 is 3, 6 plus 4 is 10, so on and so forth. So I could fairly easily do the next line. There's a 1 on each end like this. The next line will be 6, 15, 20, 15 and 6. Okay, those will be the coefficients, the numbers in front of x, or numbers in front of x and b in this case. This triangle here, you've probably seen this before. This is known as Pascal's triangle, and yeah, you can work out each line if you know the previous line, the next line if you know the previous line. So now when we're expanding these sorts of things, we can get these numbers out the front, the coefficients, very quickly now. So if we had something like x plus b to the power of 6, to get the coefficients, we won't worry about the x's and the b's just yet. We can just find the next line of the Pascal's triangle, and we can get that very nicely. Okay. The other way that you can calculate all of these terms here, so all of these numbers, is by using a little accounting method. I guess this is where you saw this in probability in year 11. But this idea is, we can use the formula NCR to work out each of these terms along here. So you need to know this formula, NCR, and this does come up in a couple of things this year. So you do need to be aware of it, remembering that NCR is n factorial over r factorial, n minus r factorial. And I'm going to say that n is the row number, and we start at row 0, and then go to row 1, row 2, so on and so forth. And r is the term number starting from 0. So the very first term, so if you had x plus b to the power of 0, the expansion of that one, or the coefficient would be n would be 0 because it's the row number of 0, and the term it's the first term, and the first term we start at 0. So therefore it'll be 0 c0, which of course will be 1 because 0 factorial is 1. I'm not really sure why that is. I'll have to investigate that another day, but 0 factorial is 1. So I mean that's not very useful because you never really expand anything to the power of 0. It's always going to be 1 anyway. But let's if we just take say number 2 here, we know the numbers of when you expand x plus b to the power of 2, you're going to get 1x squared plus 2xb plus 1b squared, like this. So we need to get those numbers, and the way that you can do that is by using the NCR. So we can say, if in this case n will be 2, and r will be, depending on the term, this one will be the 0 term, this one will be the first term, this one will be the second term. So you can use this formula up here, and we can say 2 factorial over, let's work out the first term, r factorial, so that's 0 factorial over n minus r, which is in fact 2 factorial. So it's 2 factorial over 2 factorial, and you're remembering 0 factorial is 1, so therefore we get the answer of 1, which we knew that, but it's nice to prove it as well. So now we don't need Pascal's triangle so much anymore. We don't have to memorize all of those lines. We don't have to add things together and all that sort of stuff. We can just use NCR to find out the coefficients of any term. We could have any row, any expansion, x to the power, x plus 3 to x plus b to the power of 12 or whatever. We could find out all of the coefficients from that. It would be a lot of calculations, but we could find it out fairly quickly and easily. So the next thing I want to focus on, again, we're trying to look for patterns. I want to go back up to this thing here, and I guess I want to notice what's happening to the powers on each of these terms. If we look at the first term, x, and the second term of b, what's happening to the powers as we go through this triangle? Hopefully you realize that the powers of x actually decrease from the maximum at the start down to 0. Let me just write x to the power of 0 there. Okay, so this one goes from x to the power of 2, x to the power of 1, x to the power of 0. This one goes x to the power of 3, 2, 1, 0. So they descend from the highest power, which is 3, to the lowest power, which is 0. Now let's have a look at the b's. They in fact do the opposite. So we get here, we got b cubed, b squared, b to the power of 1, and over here that would also be b to the power of 0. So b actually, the powers of b actually increase from left to right, and you can have a look at that all the way down the Pascal's triangle. So again, we can start to think about expanding something that's quite difficult for us, say x plus b to the power of 5, rather than doing x plus b times x plus b, then doing another one times x plus b, and so on and so forth. That would actually take quite a long time. We can work out the expansion of it by, 1, finding the coefficients using Pascal's triangle or the NCR stuff, and then 2, we can find out what the powers are of each of the terms just by decreasing the power of the first term and increasing the power of the second term, so that we go right throughout. I think that's what this one here says, yeah. So notice the powers of the first term on each line. Do you notice any patterns? Will they decrease the powers from the maximum, or the original power, if you like to call it that? And this one here, the second term, they increase the powers from 0 to the maximum. So what I might do is I might just have a go at just the first question here, and then I'll let you do some of the rest of them, and also some of exercise 1.1, I believe. So they can get a little bit tricky, as you can see here, x on 2, and 2x makes things a little bit more complicated, but I'm just going to have a go at this. Now I could expand it the old-fashioned way, but I can't be bothered because it's x to the power 4, so something to the power 4 is going to be way too hard for me to do. So I guess the first thing I'm going to do is I'm going to write down the coefficients of each of them. Now I'm going to just use Pascal's triangle, though I could easily use the NCR bit. I do find the Pascal's triangle easier to remember, I guess, because you can sort of just remember. You usually probably remember that the first 3 lines very easily. Probably remember the fourth line, and then if whatever power you've got, you just kind of add a couple more lines and sort of work it out that way. If it's in an exam, if I've got my calculator, I'll probably use my calculator to do NCR. But if I don't have my calculator, I might sort of look at the Pascal's triangle a little bit more. So I had x to the power of 4, so the coefficients are here 1, 4, 6, 4 and 1. So I'm going to write those down here. I'm going to leave myself a little bit of space in between each one of them. 1, 4, 6, 4, 1. Hopefully I've got a little bit of space at the end. I think I will. Now I'm just going to write each term. I'm going to start with the x terms. I'm going to write all of those there, and then I'm going to decrease the powers. I probably don't need to write it here. I will, but I don't need to. It's going to start from x to the power 4, go to x to the power 3, 2, 1, and then 0. And then I've got the other term, which is 2, and that will start at 2 to the power of 0, and then 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and finally 2 to the power of 4. Now what's going to happen with this, I mentioned, we found out the coefficients before of 1, 4, 6, 4, and 1. It is true, but let's just have a look at what happens when we actually do 2 times 4 and 2 squared times 4 and so on. This will be x to the power of 4, because 2 to the power of 0 is 1 anyway. Then you're going to have plus 8x to the power of 3, plus that's 24, sorry, that's 4, and then 4 times 6 is 24 x squared, and then 2 cubed is 8, 8 times 4 is 32 x, and then finally plus 16. So my coefficients are actually not what they were originally, 1, 4, 6, 4, 1, but they're instead different ones, because I had to multiply them by the 2. The only other thing I'll add to this is that when you have a negative instead of a positive, it changes things a little bit, because all of a sudden, instead of having 2, if that was a negative there, I'll do this in red just so it's a little bit different. If that was a negative 2, then that means that this one here would be negative 2 to the power of 1. And obviously that term would be a negative, so this term here would be a negative. But then this one, it would be negative 2 squared. Now that turns into a positive, so that one would be positive. So what you'll end up having is positive. You'll have them fluctuating. One will be positive, negative, positive, negative, positive, negative, all the way throughout your expansion. But I'm sure if you do it, do it the correct way, you'll probably be able to find the answer for yourselves. So that's the binomial theory. Hopefully you understand that. If you've got any questions, please feel free to ask me. Have a go at these questions here, and then also some of the questions from your textbook. Thanks very much.